So this is the video for the second half of 8.5. Previously we talked about solving exponential equations by getting the same base. And so we went through several examples. We got the same base on both sides, and then we set the exponents equal to each other. Well, remember I said there's two methods to solving exponential equations. It might be that you can't get the same base on both sides. So for example, when I look at number 1, I have a 10 on the left and a 4 on the right. I could write 4 as a base of 2, but I can't write 10 as a base of 2. So I can't get those to be the same base. So that's when we use this second method. Now, I want to kind of draw your attention to 8.6. We already did 8.6, and remember we learned how to solve log equations. And what we said was, we said isolate the log, we said change it to exponential, and then solve for x. Well, let's see, I'm going to duplicate that, and let me move that up here because I just want to show you a comparison. Just hang with me a second. I'm going to pull that up here to the notes that I'm getting ready to talk through. Almost there. Okay. So let me kind of make this a little bit smaller so it'll fit. All right, so remember this was our method for solving a logarithmic equation. Okay, so what did we use this for? We used this to solve a logarithmic equation. Let me just kind of squeeze that over here a little bit. All right, so we used this to solve log equations, right? That's what we used this for. So we said isolate the logarithm. Well, guess what? When we are solving exponential equations, because that's what we're doing here. When we're solving exponential equations, our first step is not going to be to isolate the log like before. It's going to be to isolate the exponential term. Isolate the exponential term. Last time we were once we had the log by itself, we said to change to exponential form. Well, now, once we have the exponential term by itself, we're going to change to log form. And then last time, after we had it in exponential form, we said solve for x. Well, now, after we have it in log form, we're going to solve for x. So I just wanted to show you these kind of side by side because really you do the same thing. You change it to the opposite. Well, let me back up. You isolate the term, you change it to the opposite form, and then you solve for x. So take a look at my first example. It says isolate the exponential term. Well, the exponential term is the term that has the exponent. So 10 to the x plus 1 is the exponential term. Okay, it's already by itself. Step 2 is change to log form. Well, remember how to go back and forth. We would say log, which part of that is the base? The base is 10. So we say log base 10 of the answer, so of 4. And remember the log always equals the exponent, and in this case the exponent is x plus 1. So you got to remember how to go back and forth. And now, forget that log base 10 of 4. That's just a number. I mean, if I wanted to know what decimal it is, I could put it in my calculator. I don't want it as a decimal, but it's just a number. There's no variable there. I'm trying to solve for x. That means I'm trying to get this x by itself. Well, all I have to do is subtract 1. So x is going to be whatever log base 10 of 4 is minus 1. And since that 1 is not a part of the logarithm, you don't change this to say log base 10 of 3. You can't combine those. So that is my answer. Okay? So let's look at number 2. So step 1 is to isolate the exponential term. Well, this is the exponential term because this is the part that has the exponent. It's already by itself. Step 2 is to change to log form. Well, I would say log base e, but remember if it's a base e, we write natural log. So natural log of the answer, and remember the log always equals the exponent, so equals x plus 1. And again, natural log of 4/5, that's just a number. If I'm trying to solve for x, I'm trying to get x by itself, so just subtract 1. So x is going to equal the natural log of 4/5, and then whatever that is, minus 1. Okay? Look at number 3. So first step is the exponential part by itself. Well, this right here, the 5 to the 3x, that's the exponential part. So in order to get it by itself, I'm going to have to add 10 first, and then I'll divide by 2. So if I add 10, I'm going to get 14. And then if I divide by 2, I'm going to get 7. So I've got 5 to the 3x equals 7. So I did 2 steps to get to the 7. Okay, now I'm ready to change to log form. So I would say log, what's the base? The base is 5, log base 5 of the answer, so of 7, equals the exponent, which is 3x. Okay, so again, if I'm going to try and solve for this x, what am I going to have to do to get rid of 3? I'll just divide by 3. So x equals whatever log base 5 of 7 is, all divided by 3. Okay, so I never said the answers were going to be pretty. As long as I get the x by itself, and then there's no other x's left on the other side, you know you're done. So when I look at number 4, step 1, get the exponential part by itself. All right, this is the exponential part. It's already by itself. So then I change it to log form. So log base 7 of the answer equals the exponent. So equals x minus 3. And last step, I need to get the x by itself. So I'm just going to add 3. So x equals whatever log base 7 of 3 is, and then plus 3. Okay, and that's it.